Welcome to NASA Edge, an inside and outside look at all things NASA. We're here at NASA Goddard Space Flight Center talking to the MMS team, or the Magnetospheric Multiscale Mission. How you guys doing?
Great. Doing good.
Feeling pretty good?
Yeah.
I think we have a launch coming up here in a few months.
Yeah, 6 months.
So what we're going to do today, this is unlike any other NASA Edge show we've done before. This is sort of a talk show format, and we're just going to have fun with this today, okay? So Craig, you're the PI for the key instrument on the spacecraft. Tell us a little bit about it.
Well, I think you're talking about FPI, Fast Plasma Investigation. We measure the distribution of electrons and ions in space in the reconnection region, and the thing that sets it apart is it's 100 times faster than plasma measurements have ever been made before, which allows us to get very high spatial resolution as well as time resolution, because the things we're looking at are moving past the spacecraft very quickly, so high time resolution gives us high spatial resolution. It's been a huge effort. We've got a great team, and so far so good.
Well, you have a great group right here, and Brent, as the Deputy Project Manager, Craig mentioned this term magnetic reconnection. I mean, what made you guys think about magnetic reconnection years ago when you were developing this mission?
Well, magnetic reconnection is a physical process that happens throughout the universe. It happens in planet formation, it happens in fusion reactors, and it happens in the Earth's magnetosphere. And it's just a process that scientists don't understand. It releases a tremendous amount of energy when it occurs. So NASA decided a while ago that this was a #1 priority to build a mission to understand this process.
And when did you start this mission? What year was this?
The mission was confirmed in 2009.
2009?
Yes,
okay.
It's been a while.
Now, I understand, I was reading on NASA.gov that there was another NASA spacecraft that accidentally recorded a magnetic reconnection. Is that true?
There have been several missions flown by NASA and other international organizations where we've gotten glimpses of what's really going on with magnetic reconnection. But this is the first mission which is fully dedicated in a systematic way to studying that phenomenon.
Nushi, 4 spacecraft. Why not 1?
Well, we can't meet our science requirements with just 1 spacecraft. We actually need all 4 to fly together in the tetrahedron formation to be able to do the science properly.
Now, as a systems engineer on the project, what is your role in the mission?
I'm actually the avionics systems engineer, and I actually started off as the hardware lead for this command and data handling. And I moved up to become a systems engineer. The avionics systems engineer is responsible for most of the spacecraft electronics on the deck. That includes the command and data handling subsystem, the power supply electronics, the engine valve drive, as well as the navigator, which handles our GPS and our location.
Now, is it fair to say that Nushi's doing a pretty good job as systems engineer for the project?
She's all right.
She's all right? She's okay?
I seem better.
You seem better? Okay. All right. And Kenny, you're a mechanical engineer on the project, so do you pretty much watch what Nushi's doing, making sure she's doing her job correctly, or what's your role?
Actually, I'm the mechanical lead. I actually started the project in 2005 when we were in the Integrated Design Center. So I was actually one of the ones that laid out the octagon shape that eventually came to be favored by the PI and the scientists, such as Craig.
And so why did you choose an octagon shape?
Well, the key role or factor that led to that shape was the number of instruments, and Fast Plasma Instrument has 8 instruments that are 90 degrees apart. And so that was a good function, but in the octagon, 8, goes into those 4 instruments well, and being 90 degrees apart helped with the layout a lot, and each one wanted to have their own clear field of views.
So I guess it's fair to say that you did really well in geometry back in high school and college?
I don't know if I can remember back then, but I guess so. But it wasn't just me. I would say that it was a team effort that had to go into getting that layout to be accepted.
Now, you brought up a good point, and Craig, I'm sorry you're the only scientist here. You're kind of outnumbered by engineers. The scientists and the engineering really have to work together closely in order to develop a plan for a mission. How is it important, you as a mechanical engineer, to work with the scientists?
It's very important that the scientists and the engineers work closely together so we can understand the requirements. And as we started off early on, the requirements weren't all known, so it's a lot of interaction that has to go on multiple times of cycles to try to make sure you understand and get all the requirements in so that you can package the spacecraft or build a spacecraft bus, in my world, that meets their requirements.
Now, I understand, Chris, you're also a mechanical engineer. Mm-hmm. Work with Kenny?
I do. I work for Kenny.
And was his answer correct?
Mostly.
Mostly?
No, very correct.
Is there anything you want to add to that in terms of working with the scientists?
My area of work on the project really doesn't deal a lot with the scientists. By the time I came on, which, Kenny, I think that was, what, 2010, the requirements were all pretty much well-defined, I think.
So at that point, if you didn't agree with the octagon shape, you pretty much had to deal with it because it was already set in stone by the time you got there.
Too little, too late.
Too little, too late. All right, good. Safety is really important for a lot of missions, isn't it? And I believe, Michelle, you're the safety lead for the mission?
Yes, I am the safety lead for the mission.
So in terms of safety, is your role to make sure everything is going well with the spacecraft? Or, I mean, what exactly is the safety officer?
So it's a little bit of both. My main focus is definitely making sure we keep the people safe. What I want to make sure is, anytime they're running procedures or doing different operations, that we're making sure they're within the limits, definitely within OSHA and also within the NASA requirements as well. We do also keep an eye on the hardware as well and make sure that that's safe, as well as, we have some deployables, so making sure basically if we went ahead and deployed one of those items, we're not going to hit a person or any other equipment or any other hardware on the spacecraft itself.
So you're the one that's pretty much deploying, putting in GoPros in the clean room, make sure everyone's doing their job, and you're sitting in a monitor and watching
It
them
would
all
be
day?
nice if it was that easy, but more times than not, I am the GoPro in the clean room.
You are the GoPro?
Yeah.
Wow, the human GoPro. We gotta trademark that one. Have you caught anybody in the clean room eating? Maybe some pizza, having some lunch,
No, I have not, but that's not usually what I have to worry about. So normally contamination will worry about that. So
You don't have any dirt you can give me on the team? Any of these people here? No?
Not really, no. Everybody's pretty good. Everybody takes safety pretty seriously. So we definitely have a good team of people working on this mission.
I want to go back to 4 spacecraft, 4 identical spacecraft. Are they truly identical, Brent?
They're pretty identical. They're, if you look at them to the naked eye, you couldn't tell the difference. But there's little things. These are very complicated spacecraft. So, if we find an issue with one, we might have to fix something in a different way that we fix others. So there are tiny differences.
Now, I understand informally, have you named each spacecraft? Because I always wondered, with 4 identical spacecraft, you got to have a name for each one.
1, 2, 3, and 4.
That's pretty good. So with 4 spacecraft, there's a lot of testing going on. Probably the same test repeated four different times because you have 4 identical spacecraft. And I understand Mr. Freeze is in the back, Rommel. We had you on a previous show. Great job, by the way.
I was. I'm famous now, by the way.
You were
in
in
the Philippines only, though.
So how did it go with after all 4 tests were done in the thermovac?
Overall, good. I don't miss NRL. I'm just kidding. NRL was lovely.
And what's NRL?
The Naval Research Lab down in D.C. So yeah, 6 months or more of testing, almost nonstop, and it went well.
We talked about, sometimes you were falling asleep during the test because not much was going on. I mean,
you get tired.
You get tired, okay.
Yeah, and when people are not around, you take a doze every now and then. But but again, it went well. So
very good. Ruth, you're the quality engineer on the mission. Tell us your feelings at this point in terms of MMS. I mean, are you getting excited towards the launch?
First of all, I am one of several quality engineers on the team, and I am very excited. This has been a great team to work with, great communication, great competence, and we're a team of compassion also. Highs and lows in this project has been great.
And what's, as a quality engineer, what's your role?
I assure the mission in far as like I'm not involved with the scientists, but as soon as those requirements are flowed down through engineering and into manufacturing, integration, test, we assure that those processes and the products comply with the requirements. So we're all over the place.
All over the place. So it's interesting. So Craig, as a scientist, is it fair to say, are you working with the mission all the way through? Or are you sort of there at the beginning to look at the requirements, get the instruments built, and then you're ready to get that data once the mission's underway?
No, the scientists are deeply involved from start to finish, particularly at the instrument level, which is where my function is. I have a team of engineers which I work with here in Building 21, and we interact every day. The requirements need to be set, defined as early as possible, and as clearly as possible. But then there's always things that come up. will this work? Is this good enough? Will this contaminate your measurements? Will this work or will that work? And you have to interact with the engineers, certainly at the instrument level, on a daily basis to make those kind of clarifications.
Now this mission is very unique in that you're going to be really going into the harshness of space. I mean, you're going to be experiencing a lot of radiation on this mission. So your scientific instruments really have to be ready to go and really essentially can't fail. So, I mean, what does it take to get that instrumentation ready for space?
Well, regarding the radiation environment in particular, there are certain things which are sensitive to radiation. For example, certain electronic parts. There's technology where these electronic parts can be hardened against radiation. And so we buy those particular parts for flights on a mission like this. Also plastics. You have to worry about the degradation of plastics with the radiation. But really comes down to, clear requirements and attention to detail in the implementation from start to finish.
Roberto, we have a power systems guy over here. And Roberto, I understand there's some solar panels on the spacecraft, along with some batteries. So how do you go about designing, getting a mission like this ready for solar panels and batteries and making sure that the instruments have enough power on board?
We do what's called the energy balance analysis, which dictates, based on the orbit, how much solar array we're going to be needing and how much battery we're going to be needing for the long shadows. In particular, the MMS mission was challenging. We're going to be in eclipse for about 4 hours. But we also were facing the wall in terms of how big the battery could be, because there's a mass that we need to keep the whole spacecraft below the number. So we have to go back and forth, and we came up with different what we call flight operational scenarios, where we dictate what instrument gets turned on, which one gets turned off, so that we have enough battery power to come out of the Umbra.
Okay. So it's not as easy as just putting a bunch of Energizer bunnies inside the spacecraft.
I wish it was.
Now, we talked about 4 spacecraft. I mean, do you need 4, Brent? Do you need 4 spacecraft to complete the mission? Could you get away with 3 or 2?
For 4 science, we need the full 4 spacecraft. Magnetic reconnection is a process that happens in 3 dimensions. So you have to take measurements in 4 different parts of space. So you really need the 4 spacecraft. We could do minimal science with 3, but we're aiming for 4.
Now I'm going to get a little bit heavy from my perspective on the science side, so you got to help me to understand. So is it fair to say that the energy that's being transferred from the sun through the magnetic field, it actually crosses the magnetic field of the Earth, and that energy gets transferred to our field? And then, so that's sort of what you're measuring, that magnetic reconnection, to see how much energy is being transferred to our field? Is that fair to say?
Yeah, you could think of it as there's energy stored in our magnetic field, and energy is released during a magnetic reconnection. When the sun's plasma interacts with the Earth's magnetic field, there's energy that's released from that magnetic field.
The only visible signs that there is really a connection between the sun and the Earth is the auroras. So on the back side, I guess, you're looking at reconnection as well?
Yeah, that's phase 2 of the mission, is looking at reconnection and what we call the magnetospheric tail. We can't execute both phases simultaneously because when reconnection happens on the sunward side of the Earth, it's about 11 Earth radii away, or upstream from the Earth. Okay. When it happens on the backside in the magnetospheric tail, it's at about 20 Earth radii away. So we actually have to execute propulsive maneuvers and change our orbits between phase 1 and phase 2.
Now, speaking of propulsion, how long is the mission supposed to last?
Well, it's a 2-year mission. We have a commissioning period of about 5.5 months, and then we have a 2-year science mission.
Okay.
So the spacecraft will be up there for at least that long, and then we have fuel that, if NASA chooses to, we could extend the mission by probably another couple of years.
Nish, a lot of times I talk to a lot of high school students, college students, and the term systems engineer. What exactly is a systems engineer, and how's the schooling different than, let's say, a mechanical or an aerospace or an electrical?
Well, systems engineering, it's very different in different areas, but for me specifically, I have many different types of roles. One of my roles is to make sure that the requirements are met technically properly. We also have to make sure that we test the observatories properly, and that was probably one of the biggest challenges for MMS. We have 4 observatories, and we have a lot of tests to run. At this point, I've lost track of how many functional tests and CPTs, and of course, Ramel mentioned we had
CPTs?
comprehensive performance tests.
Very good.
And Ramel mentioned we had 6 months of thermal vacuum testing. So one of my responsibilities was architecting those tests and making sure that we test the observatory fully, that each subsystem gets a good go at this thermal environment, or even during EMI, other vibration testing, make sure we test properly so we haven't broken anything, or that we meet all the requirements that we have to do.
So does each spacecraft have its own personality, would you say?
Some of them do. We have some observatories we always make fun of a bit. Oh, that's Observatory 4 with all the chassis current. It's pretty noisy. But, you know, they have their own personalities in terms of the people that work on it. We have a great team, but each one is known to be a little bit different from one another, and so...
Oh, so not the same team doesn't work on each of the spacecrafts. You have different teams.
It depends on what area. The mechanical team, yes, they work on all the observatories. We have a certain different number of people that work on the testing in terms of our test conductors. There's a group of people assigned to each observatory. That's not to say they don't cross-test when needed, but we have specific people assigned to those.
Now, you said you worked on each spacecraft, Kenny. Do you have a favorite with one of the spacecraft?
It's blue. Blue is a favorite color.
Yes. Yes, Ops 2 was built first. Our build order was 2143.
2143?
Yes, sir.
Is that new math, or is it usually because it's 1, 2, 3, 4, isn't it?
Random, you roll the dice.
That's how you do it now? You just roll the dice and whatever comes through? Okay.
It actually came about as a result of as the spacecraft were building early on, we had some problems in one of the test facilities, and so that's what facilitated that change.
So when you were working on spacecraft 2, did that get fully developed first and completed first before 1, 3, and 4? Or how does that work?
Pretty much.
Yeah,
so.
yeah, it did.
It did?
It did. Yeah. Number 2 went through all the entire integration first, and the others followed in a staggered fashion.
And how cool was it to you see the first pictures of the stack? You have all 4 on top of each other, because that's how it's going to be launched.
That was
Correct?
cool.
Was that cool?
Very cool. That's very cool.
Tall stack.
Yes.
Now,
21
I understand it's going to be
feet.
going on an Atlas 5.
Yes.
Okay. Which leads me to sort of the next phase is you've built the 4 spacecraft, right? You're in your final testing phase before it gets shipped down to Kennedy Space Center.
Yes.
What is that process of going through and packaging the spacecraft, getting it ready to ship, sending it down to Kennedy, getting it unshipped, and getting it processed for the launch vehicle? Is that part of your job too?
Yes. Actually, it's our job in the mechanical realm. So our team built what's called a transporter, which we use to transport the satellites from Goddard to the launch facility, which is going to be Astrotech. So we have to build that, and we're shipping a stack of 2 spacecraft.
Okay.
So we have 2 shipments from here to Florida.
So pretty much what you're going to do is you're going to tell Chris what to do in terms of how to stack those spacecraft.
Well, Chris has helped with stacking them, but actually there's other people on our team that are actually, we've been going through all the different tests and getting a lot of practice in actually transporting the spacecraft from Goddard to NRL to support Ramel's thermal vac testing. So we'll have to repeat that process, but it'll be a little different because we'll be carrying a stack this time versus a single spacecraft, and it also be using a new transporter that we have never used before.
What kind of transporter is that?
This one's an all-one complete transport system, transporter and trailer. Normally in the past, we would transport on the trailer and stick a shipping container on the trailer, but this is built all in one, and it has steering, front and rear steering, so it gives us more mobility and flexibility in transporting, so it should be a nice, smoother ride.
Now, I guess you have to be careful in terms of vibration and all that, make sure nothing breaks on the spacecraft. So is it much safer to actually transport it by highway as opposed to flying it down?
Well, this space, early on we had to make a decision in the requirements to design the structures for flight loads or over the road or transporting over the ocean, which we have done at NASA before in the past, but this was decided early on to just transport over the road. So we have isolators or shock systems basically in place, and also environmental controls in place actually to do it.
Now, Chris, as a fellow mechanical engineer, what would you say was the most challenging part of your job working on MMS?
Probably the most challenging thing would be probably going from clean room to clean room. There was always something going on one observatory. Normally in a spacecraft where there's one, you might stand down for a little while, thermal needs to fix something, or electrical, or any propulsion, any of the other subsystems need to work on something. Whereas with MMS, with 4 spacecraft, there was always something to do. Whether if one was busy with one of Nusha's functional tests, then 2 needed solar arrays put on, or number 3 needed to go up on an Aronson table, or we needed to do a vibe test or an acoustic test on number 4. So there was definitely always something going on something, very, very little downtime.
And Ruth, and with those 4 spacecraft, making sure you have quality assurance, I mean, that has to be challenging because you have to keep track of 4 spacecraft.
Yes, actually, it's very challenging, but the quality engineering team, we're really good about you can just plug and play us whatever observatory is needed.
We're flexible.
Attention. Yeah, and so we can do that well. Keeping track of all these guys to make sure that they're following processes, that was also easy. I'd like to say that basically everyone's quality-minded, so that made our job very easy.
You look like a happy bunch. You know, you guys, you can tell you work well together. Do you guys spend time after work? Do you guys have MMS parties, or you kind of have a, you know, do you have parties in the clean room after you completed one of the spacecraft? And say,
I
hey,
insist on a party after every CPT and every thermal vacuum. It even says it on the spreadsheet for the test flow.
That's one of the project requirements?
Yes, it says, Craig and Brent, throw us a party.
I don't think I've ever been invited to one of those.
I defer to Brent on that one.
Brent?
I think mechanical was left out on that.
It's invitation only.
Invitation only. Well, you know, thank you so much, you know, for joining us today. We look forward to a great launch on top of the Atlas V in March, and I'm sure you'll be down there, working hard, preparing for the launch, but also, you know, just the feeling once that, you know, rocket achieves orbit and it gets into space, you can say that you actually have a spacecraft orbiting the Earth. And 4 of them, yes, that's right, 4 of them, that's right. And how soon will you get the data back once the spacecraft is functioning?
Well, like Brent said, there's about a 5-month commissioning period.
Okay.
So we launch in March, you know, around August, the scientific harvest will really begin.
Okay. Well, everyone, thank you so much for joining us here today. It's been insightful. And when we come back, we're going to be joined by another 7 folks on the MMS team to see if we can get some dirt on these folks here. We'll be right back.